Talk today about section 8.2. We are talking about page 558. And this is going to be simple rational functions. Now, by simple, what we mean is uncomplicated by extra stuff. What we also mean by simple is that these are going to be predictable. Every single one of these is going to give us the same shape. Now, where it's going to be and which way it's facing, whether it's flipped or not, that is different. But we know what the shape is always going to be. In the next section, we're going to do general rational functions. And on general rational functions, we can't predict at the beginning what the shape is going to be. Until we start actually plugging it in on our T-chart and drawing the graph, we're not going to know what the picture is going to look like. But these we do. So, what we're talking about is a function, for example, that looks like this. This is a simple rational function. A rational function is something that's of the form y equals f of x over g of x, where f and g are some polynomials in the variable x. Now, the top one can be just a constant polynomial, a single number like 3. The bottom one has to be a polynomial that actually has an x in it. There has to be a variable on the bottom. There doesn't have to be a variable on the top. Okay, so 3 over x is fine. X over 5x minus 1 is fine. These would be some other rational functions. 7x plus 3 over 8x minus 2. These are examples of rational functions. There's always going to be at least an x in the denominator. Otherwise, it's not a rational function. It's just a linear function. Okay. So we're going to graph this one. When we go to graph this, we're going to do this using a T-chart. And to do this using a T-chart, what we're going to do is we're going to just pick some generic points to plug in for now. We're going to change that in a minute. But for right now, we're going to use generic points. 0, 1, 2, negative 1, negative 2. Let's get our graph out here. When I plug in 2, what's 3 divided by 2? 3 halves, right? Or 1 1/2, so 1.5. I highly recommend that you guys use your calculator to help you figure these things out. Remember, you're not allowed to give me decimals as a final answer, but your T-chart is not the final answer. The graph is. So any final answers cannot have decimals, but your T-chart can. If I plug a 1 in, what's 3 divided by 1? 3. If I plug a negative 1 in, we get negative 3. If I plug a negative 2 in, that gives me negative 1.5. The problem is, what do I get when I plug 0 in? Undefined. If I try and plug 0 in for my x-coordinate, what do I get for a y-coordinate? What number do I get for the y-coordinate? Yeah, undefined means we don't get a number, right? There's no number that satisfies that. If we have an x-coordinate but no y-coordinate, where does that show up on our graph? Nope. Nope. Because that would have a y-coordinate of 0, right? So if there is no number for the y-coordinate, how do we put that on our graph? Nope, not a line, because that would have multiple y-coordinates. Somebody said it. You don't. If there's an x-coordinate but no y-coordinate, there's nowhere for me to put it, guys. Anywhere I put a dot here, or a line or anything else, I've got y-coordinates for each of those. So that we can't do. So that means that that will not show up on our graph. What that means is that x equals 0 is going to be a vertical asymptote. Remember asymptotes from the last chapter? X equals 0 is going to be our vertical asymptote. These are always, simple rational functions always have one vertical asymptote. Everybody with me on that? Do you guys see what that does to our graph? It divides it into two pieces. We have a left side and a right side. Here's the left, here's the right. And so what you're going to do when you guys do this is you are going to look for the vertical asymptote first. How do you find the vertical asymptote? It comes from our y-coordinate being undefined. What makes the y-coordinate undefined? You take the denominator and set it equal to 0. That is your vertical asymptote. Now, what if we had something like 5 over x minus 1? What would the vertical asymptote be? X equals 1. If I set the denominator equal to 0 and solve, we get x equals 1, so that's our vertical asymptote. Whatever makes the denominator 0 is your vertical asymptote. Find that first. Once you have found that, then what you do is you use that number as your divider on your t-chart, and you do two separate pieces of your t-chart, the right piece and the left piece. I would normally do the left one first, but because I already wrote those numbers in, I'll write right and then left. And then what you're going to want to do, guys, is you're going to want to plug in 3 points on each side of that asymptote. So since the asymptote's 0, I'm going to use 1, 2, and 3. What's 3 divided by 3? 1. I'm going to use -1, -2, and -3 on the other side. What's 3 divided by -3? -1. Now that I have 3 points on each side, I'm going to draw my graph. The two pieces are not going to connect. That's why I put a divider on the t-chart. Now, I'm not always going to use 1, 2, 3, -1, -2, -3. I'm going to use the first 3 points to the right of the asymptote and the first 3 points to the left of the asymptote. Does that make sense to everybody? That's how you pick your values for the t-chart. The asymptote will determine what you plug in. So now I have 2, 1.5. I have 1, 3. I have 3, 1. And what this does, guys, is this goes like this. It's got to start moving towards its asymptote. Its vertical asymptote. The question is, what happens with the other end of that curve? And it turns out that what happens here, guys, is that we also have a horizontal asymptote on this graph. On this particular one, our horizontal asymptote is going to be y equals 0. And I'm going to show you in just a moment how you find that. But do you guys see that that makes sense with what we're seeing on the graph so far? What this thing is going to do is it's going to continue to curve down, and it's going to zoom in towards its horizontal asymptote. Make sure that curve does not touch either asymptote. It will never touch either asymptote. If it touches, I've got to dock you points because it's not correct. So make sure you draw the asymptotes on the graph. Otherwise, you're going to accidentally bump them without meaning to. Okay? Everybody got that? You with us? All right. Now we're going to graph the other piece. Yes, ma'am. Question on that piece? It's whatever value of x makes the denominator 0 was x equals 0, so that's how we knew it was this. I haven't shown you the rule for the horizontal one yet. I'm going to show you the rule. There's 3 parts to the rule, and as soon as we finish this, I'll show you the rule. Okay, the other piece is -1, -3, -2, -1.5, -3, -1. Do you guys see what this one is going to do? It's also going to zoom in on both its vertical and horizontal asymptotes. This is our graph. We're done graphing. Any questions about that? Is that easy enough? Find the vertical asymptote. You're going to find the horizontal asymptote. I'll show you that in a moment. Then you're going to plug in 3 points to the left of the vertical asymptote, 3 points to the right, and then you're going to draw the two pieces. What is this shape called with these two branches on it like this? Anybody know what this is called? This is called a hyperbola. Hyperbola, but that's how it's spelled, hyperbola. It's pronounced hyperbola. This is a hyperbola, guys, and every single one of the graphs in this section only are either going to look like this with one in the top right and one in the bottom left, or it could be one in the top left and one in the bottom right. They're always going to be two diagonal branches. Now, they won't always be centered at 0, 0. Okay, yes. They won't always be centered at 0, 0, but they will always have a vertical asymptote, a horizontal asymptote, and have two branches like that, diagonal from each other. That's part of what makes these simple rational functions. Starting tomorrow, they won't necessarily be hyperbolas. We won't know ahead of time. But tonight, if you get something that's not a hyperbola, you made a mistake. Every single one of these will be a hyperbola, guaranteed. Okay, any questions about the graph? Now, what I want to talk to you guys about is I want to talk to you guys about domain and range here. I haven't shown you yet. I'm going to show you that after we finish this example. There's a three-part rule for it, which we'll go over in just a moment. So for right now, take my word for it. And then we'll come back and see where that came from once I show you the rule. All right, guys, domain. So domain is x or y? Which one? X. This is x, right? Range is y. So we're going to look at the x-axis. So if I shine a light from above and I shine a light from below, the light from below will hit this piece and cast a shadow where? On the x-axis. Will it cover the whole x-axis or just part of it? Less than 0. Do you guys see that? It's going to shadow the whole x-axis less than 0. Everybody see that? Do you see the light from above is going to hit this piece and it's going to cast a shadow on the x-axis? Where's that piece going to cast a shadow on the x-axis? Everywhere greater than 0. Do you guys see that this gives us the whole x-axis except for what? 0. So there are two ways to write that. One way to write that for domain is all real numbers except x equals 0. All real numbers except x equals 0. There is a shortcut for writing that, guys, and I would use the shortcut. It means the same thing, but it's easier to write. And that is x is not equal to 0. If we state that x is not equal to 0 for the domain, that implies it's all other real numbers. That's the only one it can't be. Because domain and range only involve real numbers. Yes, ma'am? Okay. So this is a piece of metal, right? And if this light is shining down on it, do you see that this thing is going to cast a shadow down like this? And this thing is going to keep going, 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 going. But it starts just to the right of 0 because this thing never hits the asymptote, right? So there's a little teeny tiny bit of daylight in there. Does that make sense? And then this piece is going to cast a shadow like this. And so if you want to color this thing in, if that helps you see it, by all means, go ahead and do it. I mean, go back and erase it because it's not part of your graph, or just do it very lightly. But I think just even if you took your pencil and just pretended like you were doing it, you'd see it. Does that make more sense? So it's the whole x-axis except 0. Now, what happens if we look at our range? If we draw our shadow going this way, because the lights are coming from the right and the left. Do you guys see what it's going to cover on the y-axis? It's going to do all of that. So it's going to be the whole y-axis bigger than 0. And it's going to go like this, which is the whole y-axis less than 0. So what is our range going to be? Do you guys see a connection between our two asymptotes and our domain and range? What was our domain? X is not equal to 0. What was our vertical asymptote? No, vertical asymptote. X is equal to 0. So the asymptote is a line. It's got to be an equal to. The domain tells us that that's the only thing we're not going to get for x. So that's why x is not equal to 0. Notice our horizontal asymptote is y equals 0. Our range is y is not equal to 0. Do you think that is always going to hold for these simple rational functions? Yeah, it's part of what makes them simple. Now, in the next section, that won't be the case. Okay, we'll talk about domain and range in the next section when we get to it, but that won't be the case. It'll be a little bit more complicated. You can still find it with the shadow thing, but you're not going to be able to look at the asymptote and automatically know what domain and range are. Okay? Now, again, don't actually shade this stuff in, or if you do, you got to go back and erase it, guys. So I should have used a different pen so I could just grab it and pull it out of the way, but you guys get the idea for the graph, okay? Domain, range, graph, vertical asymptote, horizontal asymptote. Any questions on that other than where the horizontal asymptote came from? Morgan?
look at the vertical asymptote
and see the domain.
Range, but tomorrow it'll be different.
Right. Or in the next section, I should say.
Okay.
May or may not be tomorrow. We'll see how it goes.
So, like, if the equation was x equals y equals 3 over x minus 1, and then x equals 1,
would be your vertical asymptote, so your domain would be
x is not 1.
not equal to 1. Because this line, this break line would be at 1, and so you'd have everything to the right and everything to the left. So that's exactly right. It would hit 0 if this was x equals 1, because this whole thing would shift to the right 1 unit, so this piece would have been over here more, and it would have hit 0. But this one doesn't, because we don't have a minus 1 on the bottom. All right, can we take a look at the horizontal asymptote rule? So I told you that the horizontal asymptote is y equals 0. Let me show you where I got that, because it's not magic, guys. There is a 3-part rule for horizontal asymptotes. What you do is you look at the highest power in the function. There are 3 different possibilities as to where that highest power can be. I'm talking about the highest power of x. Okay? So highest power of x in the function. Possibility number 1, it can be on the top in the numerator. Possibility number 2, it can be on the bottom in the denominator. Possibility number 3, it's both the top and the bottom. So what do I mean by that? Let me give you an example. Y equals 3x squared over 5x minus 7. What is the highest power of x? 2, x squared, right? Where is it? The top or the bottom or both? Top. So since the highest power is on the top, that's category number 1. What happens when the highest power is on the top? Your horizontal asymptote does not exist. There isn't one. You're not going to see any of those tonight, because I already told you that tonight you always get one vertical asymptote and one horizontal. So this will not occur tonight. But starting tomorrow it can occur, or in the next section I should say. Questions about that? Everyone's okay? Bottom, let me just flip this thing over. Y equals 5x minus 7 over 3x squared. Where's the highest power? On the bottom. What happens when the highest power is on the bottom? The horizontal asymptote is y equals 0. Everybody got that? Going back quickly to our example, where was the highest power? What was the highest power, first of all? X to the first. Where was it, top or bottom? Bottom, which makes the horizontal asymptote what? That's where I got that from. Does that make sense now? Now, I haven't explained why these work the way they do. We'll talk about that in a minute. Okay. The highest power on the top won't give you a horizontal asymptote. I'll explain why in a minute. Both, meaning you have y is equal to 10x cubed minus 7x plus 1 over 5x cubed plus 4. What's the highest power of x? 3. Where is it? Both the top and the bottom. When that happens, guys, what you do is you just reduce those two terms. So you look at the y equals 10x cubed over 5x cubed. You ignore these guys. Okay? Let me get rid of those lines, but that's what you do. What does this simplify down to? Horizontal asymptote then is y equals 2. Now, will it always be 2? No, it's whatever that reduces down to. So the top one always gives you none. The first one always gives you none. The second one always gives you y equals 0. It's the bottom one that gives you y equals whatever that thing reduces down to on your particular problem. So does everybody understand what the rule says? I know you don't understand why the rule says it, but you understand what the rule says. It's a pretty basic rule. Highest power on top, no horizontal asymptote. Highest power on the bottom, y equals 0. Highest power on both, just ignore the smaller power terms and reduce what you have. Now, I want you guys to understand something. It doesn't really pop up, I don't believe, on your assignments, but this is the rule for when you just have the y equals the rational term, the fraction stuff. What would happen if we had y equals 5x minus 7 over 3x squared, this middle one, plus 2? What do you think that plus 2 at the end would do to our graph, our asymptote? It would become y equals 0 plus 2, which is y equals 2. If this, instead of being a plus 2, happened to be a minus 12, then this would have been y equals 0 from this piece, minus 12 from this piece. It would be y equals negative 12. Does that make sense? So you apply the rule just to the fraction part, and then if there's something extra being added or subtracted, you add or subtract that from whatever the three-part rule gave you. Does everyone understand that? Then if you add something or subtract something from none, you still get none. Yeah, exactly. Good question. Okay. None, right, you don't draw a horizontal. Again, that won't happen tonight, guaranteed, but in the next section it will happen occasionally. And we'll talk about what happens when it does. Okay, where this comes from briefly, guys, is this comes from something we looked at earlier in the year. Remember end behavior? When we looked at the ends of a polynomial graph, as x approaches positive infinity, what does the y-coordinate do? Go up or down? That's the idea. Where this comes from is looking at just the very ends of the graph. When x is really, really big in the positive direction or really, really big in the negative direction. What happens when x gets really, really big is that the highest power term completely takes over. And so if that highest power term on the top is on the top, as I plug in things like 10, 100, 1,000, a million, a billion, this x on the bottom is a big number, but x squared is humongous. This guy on the bottom is tiny compared to the top. It zooms off to infinity. So there's no way we can draw a line in infinity. So that's why there's no horizontal asymptote. On the middle one, the highest power is on the bottom. That means as x gets bigger and bigger and bigger, do you see how the bottom becomes huge compared to the top? What happens when you take a relatively small number and divide it by a huge number? What do you basically get? 0. Do you ever get exactly 0? No, it's just really, really tiny. It gets closer and closer and closer to 0. Isn't that what an asymptote is? A line that you get closer and closer and closer to without ever getting there? So does it make sense where the y equals 0 comes from? What happens when the highest power is on both? Well, this stuff basically disappears. All of this stuff here basically disappears, and you're just left with this guy taking control, these two terms. And isn't the top always going to be exactly twice as big as the bottom here? Right? 10x cubed is always exactly twice as big as 5x cubed. So that's why it's y equals 2. But why is that an asymptote? Why is that a line that we get closer and closer to without ever getting there? Because of this stuff. This stuff is just enough to prevent the top from actually being exactly twice as big as the bottom. That little stuff will mess it all up, so it doesn't quite get to 2. Does that make sense to everybody? Remember, we're only talking about plugging huge values of x in. Now, what happens when we plug small values of x in? Then this thing is not anywhere near necessarily twice as big as the bottom. So all kinds of weird things can happen. We're going to talk about that more in the next section. It won't be an issue today. Okay? Questions about that three-part rule before we do one more example? All right. Let's hit up one more example, and then I'll give you guys the assignment. I just want to make sure it all makes sense. So y equals 3x minus 1 over 5x squared. No, let's make this x over let's make this, sorry guys, I want to get one that's going to be reasonable. Here we go. This will work. 1 over x minus 3. That's fine. Let's do that one. Keep it easy. So, First thing I have to do is find my vertical asymptote. How do I find the vertical asymptote? Set the bottom equal to 0. Solve for x, which gives us x equals 3. Right away, grab your graph. Put that on there. X equals 3 is right there. You guys see how that makes a left side and a right side? So I'm going to make my t-chart. And I'm going to break it into two. I have a left side, I have a right side. What number should I plug in on the left of the asymptote? 210. That's exactly what I would use. What about the right side? 456. Now, before I start plugging those in, now we want to find our horizontal asymptote. The horizontal asymptote, where's the highest power of x, top or bottom? Bottom, which means our asymptote is y equals 0. So now put that on your graph. Everybody with me? Now let's plug these in. If I plug in a 2, I get 1 over 2 minus 3. That's 1 over negative 1. Sorry, let me get the tablet to wake up. 1 over negative 1 is equal to negative 1. So 2 comma negative 1. If I plug in a 1, I get 1 over negative 2, which is negative a half. If I plug in 0, I get 1 over negative 3, which is negative a third. A little bit smaller. Do you guys see what it's doing? Don't accidentally touch. I don't care if the arrowhead touches, but don't let the curve touch. So I'm going to clean that up just a little bit. But make sure you show it going towards its asymptote. That's the left piece. Any questions about that? Let's do the right piece. Plug in a 4, you get 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third. 4, 1, a half, a third. Do you guys see what this piece is doing? Again, do you see why these things are easy or simple? Because we know what the shape's going to be. Now, if there's a negative in front of the whole fraction, that's going to flip it upside down so it opens here and down here. That's how you get the other one, if there's a negative attached to the fraction. You glue that on at the end. All right, that's the graph. Questions? What's our domain going to be? X does not equal 3. Vertical asymptote is x equals 3. What's our range going to be? Y is not equal to 0. Our horizontal asymptote is 0. That's it. Randy?
I thought there was an implied exponent on all of them. 3 is the first power, y is the third power.
There's an implied exponent, but those aren't powers of x. Remember, the rule is the highest power of x. Yep, it's the highest power of x, of your variable. Okay, guys, any other questions? Okay, let me give you the homework assignment.